Hi, it's Robin. One more hurried, unscripted video with the Roaming Speccy, which has been traveling the world from the UK to the US to here in Canada, and I think soon off to Australia. Check the video description for a playlist to other videos about it if you haven't already checked that out. So I'm almost out of time to record with this ZX Spectrum, so the one last thing I have time for is to look at this sound card made by Matthew Desmond, aka Factor of Matt, author of the DesTerm 128 terminal for the Commodore 128 that I've shown in a previous video. Oh, and he also made SnapTerm, that's built into the Super Snapshot cartridge, and other things. So this card, as it says, is based on a project and article from Your Computer magazine way back in March 1983. It's on page 84, and the article, and I suppose the project, is titled Mozart Lives, and it details both a Speccy program and the original designs for this sound card. Now, today's Matt tells me that young Matt was mesmerized by this article, particularly all the pictures, illustrations, and just, I guess, the idea of this project, a sound card for the Spectrum, and this interesting software that's included. So he finally has made it all happen, implementing the card and getting the software into the computer 42 years later. Shows that you should just never give up. Matt will be putting all the information about this up on his website. If not, check out his other projects there anyway. But the main thing about this card is this AY-3-8910 by, well, at least the original was by General Instruments. It was used in the Vectrex console, in television, along with the Amstrad CPC computer, the Auric 1, MSX, and eventually became standard on later ZX Spectrum models, not this first one, but some of the later ones had one built in. It was also used in a lot of famous arcade games, including Frogger, Moon Patrol, Burger Time, Tron. I'd say most early arcade games that have memorable music probably had this sound chip in them. This chip also has two input-output ports, which I believe are accessible here through these pins. It has a couple TTL chips for some logic, has a headphone output jack, and also has a header for a speaker, so it has a little amplifier built into it, I believe. So, pretty neat little card. Okay, so I want to try out that card, but first I have to figure out how to get the software loaded on the Spectrum. So as always, there'll be a chapter index. If you don't want to see me messing around with this, I'm going to include a bit more detail about how to get the software loaded, because I actually spent hours getting this working. It was kind of frustrating, but also kind of fun. So I'll try and document this, but not in real time. I will speed it up a bit. The software Matt included on a tap, I'm sure somebody typed it in from the magazine or OCR'd it. I'll show a little bit of the article here. It's really quite a big program, and it has 2 or 3 separate files that all have to be kind of saved in the right order. There's the main program, but also some machine language and some data. So I don't think I have a way of dealing with tap files directly into the Speccy, but there's at least one command line tool available online that will convert from the Spectrum tap format. The tap file is a Spectrum emulator file format that represents the data on a tape, essentially. And other computers like Commodore 64 have a similar but different format, also called tap. So this command line tool will convert from tap to a WAV file. So this tool is called ZXTAP2WAV, and it's on GitHub by user Raydak. And it was super easy to use, just a single command line. So then I thought, I'm set. So now I can just have that WAV file on my iPad or my old MacBook or whatever, any device that has a headphone jack still. So my first mistake was that I grabbed one of these 3.5 millimeter cables, but these are stereo. So you plug in the earphone jack here and plug it in my old Mac. Okay, and you press the J key for the load command, and 2 quotes, enter. Okay, it's waiting for audio, and so I have that wave file, and we'll just play it. You can't hear anything, right? Well, but if I unplug this, okay, the headphone jack's unplugged. I plug it back in. So you see the screen reacted to the click there, to me actually plugging it in again. The screen should be flashing, stuff should be happening. The wave file is about a minute long, so it should take roughly a minute to load. So lesson number 1 is do not use a stereo cable. So I went looking for a 3.5 millimeter mono cable. Just in case you don't know, a stereo cable has 3 conductors on it, while a mono only has 2. This is what the Spectrum expects. But all the cables I had weren't just like a mono 3.5 mil straight through another mono 3.5. They were instead like this RCA jack, male RCA jack. And I had other adapters with mono plugs on them, but nothing with just 2. So anyway, I did this horrible contraption. I plug that in there. Just trust me, bro. That gives me 2 mono plugs. Okay. So now, mono plug in there and into the laptop. And we will break. We will load. Quote, quote. Yeah, you have to type the double quotes. Now we'll play again. Now, we can hear some noise through the internal speaker. It's probably a bit annoying, but also it's a nice little like diagnostic tool that you can actually hear what's going on. But the way the border is just flashing like that, I didn't know right away, but this flashing blue and red, this is not the way it should be either. There should be much tighter bars. You can hear the different parts of the file. Anyway, that's not working. So eventually I read, people online suggested that really the Speccy just wants a real loud signal. Okay, so what I did was I loaded into VLC, and it has like a volume, some sort of overdrive where you can slide the volume knob up. Basically, I got more progress out of that, but that wasn't, okay, yeah, that looks like it's actually loading. I think it's supposed to look more or less like that. But in the end, that still wasn't enough. I assume that VLC, the way it puts the volume above max, is just it's doing internal clipping, and while it sounds louder, it's probably also distorting the signal in a way that the Speccy just cannot handle. So anyway, that failed too. So then I realized what I really need is like a true amplification of the signal, and that's where my very old boombox comes in. And this thing's been with me forever. Like, I bought this in the 80s, and I didn't know when I bought it how useful just the simple line-in feature was, but many inexpensive boomboxes a kid would end up with back then did not have input jacks like this. Here's the input, and so I've got the stereo cable for it, but it doesn't matter that stereo at this stage. So what I'm going to do is just plug the boombox into the Mac, and then I'll run my horrible contraption mono cable from the boombox, headphone jack, back to the Speccy, and I found if I boost the headphone jack up at like 6 or something like that. So really, I think it's just that modern devices have this kind of volume limiter, to do something sissy like protect your hearing or whatever. Back in the 80s, we didn't believe in that. So that's when we had freedom. Okay, so I'm going to power cycle here just in case. And I'm hoping finally we'll get a good load. Okay, let's try this. Load, quote, quote. Here goes. Ah. That didn't work. Let's try again. I boosted the volume a bit more again. Oh, this is looking good. Yay! See, it found the file name. I did have multiple stages where it would recognize the file name like this, but I would still get loading error at the end. Apparently, the Speccy only fails at the very end of the program, at the very end of loading, because that is where the checksum bytes are. So the whole time it's been fine, and then it's like, oh, no, that was wrong. Pretty horrible. Okay, here's the machine language stage. So I would get to this, and then it would fail more. Sorry about the noise. That's just, this is the experience of loading on a Spectrum. Yay! Okay. Okay, so that was hours condensed to minutes. Those of you who skipped to the next chapter, here we are. Okay, so we'll give this a quick try of the program without the sound card in, because it does do something. So it says compose automatically. So we'll choose 3. I got the character 3C. Guess that means it's expecting a character input. And we'll enter the volume. And I guess we'll just go for max volume here. 6. And tempo, let's go with, 4. Okay, enter to continue. And it thinks for a little, and then it will come up with a tune. Okay, so that was the automatic random composition. So apparently this is a real thing. Way back in the 1750s, I think in 1792, Mozart released his version, or at least one published under his name. Oh, do I dare say the German? Musikalisches Wurfenspiel or something. Musical dice game in German. And apparently these were games that were actually sold, I guess parlor games you might call them. Basically, they were systems. You would roll dice and follow the rules, and music would be generated. And this program is doing that system that supposedly Mozart himself created. It's almost like it was made for a computer. It's a neat idea. Algorithmic and random music generation in the 1790s, who would have thought? Obviously, the quality of that wasn't good. You would have heard there's only one note playing, and that's because I guess realistically, the Speccy speaker is only capable of playing one note at a time. You can do really fancy stuff, I guess, to generate harmony. I remember them doing that on the PC later, but it was still pretty horrible. Okay, so we'll revisit this program. Let's get on to some good sound and stuff. So I will, of course, power that off. And now we will plug in the sound card here. It's a little bit scary plugging stuff into this thing. Okay, it's offset a bit. I guess this is actually using a shorter, smaller number of pins. This might be compatible with the ZX81 as well, which I think had a shorter expansion port. Okay, there, it's plugged in. That made me a little bit nervous. Okay, Matt also included this little speaker, cutely, safely packaged here. Speaker. Kind of neat looking thing. Okay, and there's that little 2-pin header I showed you earlier. I guess I'll just leave that there. Of course, this is optional. It also has the headphone jack having a built-in, I guess you might want to call that an internal speaker, but of course it's not internal, it's external. But okay, let's see if this works now. Did I finish that other sentence that the music was only playing the single note? I think it'd be playing the melody, the highest note. But it was actually supposed to be generating, or did generate, 3 notes worth harmony. But that's what the sound card is for. And hopefully just a nicer sounding note too. Okay, let's try and load again here. All right, I'll skip forward. Hopefully this will work first try. All right, so that loaded the main basic program, I think. And here's the machine language. Yay! Okay, so I've waffled long enough. We'll just do that automatic composition, then we'll check out the other options here. So I guess I'll still do full volume. There's actually a volume trimmer on the card here as well. Tempo. Actually not sure, is 2 faster or slower? And we'll try 2 tempo. Well, that certainly had more notes. I think there's a little bit of distortion there, but that could be the fact that I'm just hanging the speaker on my wooden table here. Or maybe I should drop the volume a notch or two. Well, let's try that direct hookup. Oh, I don't know if this is safe. I popped. There we go. Okay, so I'm just going to try and plug my old boombox here into that jack. There we go. Okay, let's try the same song again. So repeat, yes. All right. So music's actually pretty listenable. I guess it's not just doing totally random notes. It's actually selecting from a whole bunch of patterns that were all individually composed and chosen so that they kind of fit together as long as you follow certain rules. It's kind of like how the Mad Libs word game, which you might know, that generates these silly sentences, they're grammatically correct most of the time. So really it's kind of the same thing. Music can be considered a language. And this music dice game is essentially a template for musical phrases that can fit together. And I guess it is like algorithmic composition. Okay, so just to look at the other options. Okay, so this program was already pretty impressive to me just by like 1983 magazine standards. It's got like a hardware project, this interesting software algorithmically creating this music. But this is what blew me away, that this was included too. It's when it says gamble with the dice. I was like, what does that mean? But if you run that, oh, 1. Here we go. It's got these 3-dimensional dice. You know, like it's just an animation. Actually, I'm surprised by how quickly it goes. I guess the programmer got impatient. But you see, it's throwing these dice, and if you just look, they're actually accurate. Like they got the correct numbers. You look, basically this is try to keep that spirit of what the original game from back then would have had. But yeah, so it's actually simulating the dice as if, you know, you were really doing this back then. It's like, yes, the computer's doing it, but why not keep that whole kind of theme alive? So I was just blown away that they did these 3D graphics. Apparently this was machine language to make it go that fast, because obviously, well, especially Spectrum Basic isn't going to be able to draw that quick. Okay, so all the numbers are rolled, and now we press enter. And it shows all the stats of what came out of it, all the numbers. That doesn't look very random to me, but anyway. Okay, so I thought that was pretty cool. But then this next bit just blew me away. Manuscript? What? I say yes. Okay, and it draws. Like, it's slow. I'll speed this up after. I'll talk for the first part, and then I'll just speed it up in editing. But it actually draws out the staff, and then it displays all the music, note by note. Now, of course, again, this is in BASIC, so this is going to take a while. But that looks so good. Like, look at each of those. Look at those notes. So this totally took me by surprise and it blew me away. I'm super impressed that a project of this scale, that's hardware, random, like algorithmic music generation, and the 3D dice, and to actually transcribe it after with all your notes, In North America, we call them 8th and 16th notes and so on. I think they're like, there's those alternate names for them in the UK, like semi, demi, quaver, and all that. Yeah, at least 2 notes at a time. It's just rendering them. Some spots, there's going to be, I think, 3 notes simultaneous. A lot of these song types actually have kind of rules to them. It was a whole very nerdy pursuit, music back then. Now we're kind of like, oh, whatever. And yet, of course, whether we like it or not, we often are following rules when we compose music. Try to decide what sounds right or wrong or good or bad. There's usually a musical theory reason for it. Okay, and then it even lets you save it, it says, and apparently it will auto-detect if you have a printer hooked up, it will print it, but I don't think I have one of those. Certainly wasn't one included in the box, unless it works with the ZX81 printer. I think I have one of those, but I'm not even sure it works. So either you save it, it prints out on printer, or it will save to tape as well. But I am not going to try that. And if we say no, okay, and it'll do the second half. So it's halfway done. Yes, it's going to go through this whole thing again, but there was essentially 2 parts. Oh yeah, so one fact Matt says, just to talk about this while this is drawing, that the whole thing is driven by a RC circuit, and I'm so ignorant about hardware, so that's a resistor capacitor circuit that creates its own clock, which is then fed into those TTL logic chips on the soundboard. On Matt's board here, it ends up being around 1.6 megahertz, which then drives the sound chip and so on. The thing about an RC circuit, if I understand correctly, is because the resistors and capacitors in reality are physical devices and they are not precise. There's always like variation. So every time you build one of these things, even if you use the same components, you're going to get at least a slightly different clock speed. And therefore, because that's what drives the whole sound chip, the oscillators in it, the frequency is going to be different. You're just kind of telling it what kind of divider to use, and it's using that to generate a frequency. But because the values are different, the pitch will change from card to card. So if you had like 2 or 3 cards, if you put 8 spectrums together because you wanted a symphony, they would all be out of tune with each other, at least slightly, maybe very noticeably. I think Matt's thinking a better design, which maybe he or somebody else will do someday, is to drive it off the internal clock of the spectrum, which is 3.5 megahertz or so, and then they would all be in tune together. But anyway, that's not how they did it. And his goal here was to recreate this particular sound card. Yeah, and he's also suggesting that this software could be ported to the Commodore 64 or 128 fairly easily. The graphics commands, the Commodore 128 or the Plus 4, well, Plus 4 doesn't have a SID though. But anyway, it could be ported And that would be interesting project for somebody. Okay, so this has generated a new song. Let's listen to it. And a tempo. Let's try tempo of 3 this time. Enter to continue. Okay. There's a bit of a hum there, but could just as soon be my boombox or the cable or something, or just this mess of cables. And the one other option here, which I found really tedious, but you can, if you want, predict the fall of the dice. Which again, it's just funny how it's a different frame of mind. I just could not imagine what these different features do just by reading them. Predict the fall of the dice. Oh yeah, this has a bug in it. Out of memory error. If you try to run that, it works if you do it first, but if you do the other options and then come back to it, this program actually has a bug. No, I will not fix it. Not today anyway. But that's a challenge for one of you. But presumably it's just not freeing up its variables properly, whatever dynamic allocation it's doing. So if we run it again, then it's cleared out the variables and we'll predict the fall of the dice. Number on left dice. So this is very tedious, but what you can do is just roll the dice yourself, 1 and 2, or just tell them what you want it to be. You know, so if you wanted to come up with a particular musical composition, and basically you have to go through and, whoops. Oh, am I going to do this all? 5, 5. Oh, I guess I'll do it. I'll skip ahead if I don't have anything interesting to say. So this is like if you like cheating on your games, you can tell it what you rolled. 1, 3, 2, 4. I'm just doing patterns. I don't know if this will make a better sounding song or a worse sounding song. 4 and 6. 1 and 6. 2 and 5. 3. Oh, there. Okay, it gave us all our stats. Manuscript? No. I love that feature, but it takes a long time. Okay, I'm going to try volume 5 this time just to see if that changes the quality at all. Okay, I'm going to go for tempo 6. Here we go, one last song. I guess 6 is the slowest. Okay, so I'm going to pack up the Speccy, and since I don't really have anything Speccy related to include in the box, I'm going to put one of my most cherished items, one of my Commodore security badges, in the box. I hope that helps keep it safe, that Commodore security, or maybe it'll start another Speccy versus Commodore war, one of the two. And I'm actually going to hand this over to Ken of Canadian Retro Things at the upcoming ThunderCon. The Thunder Bay Retro Computer Club is going to be putting on a display at our local Comic Con coming up just in a few days here, probably in the past by the time this video comes out. So I was wondering if you had anything to say to ZX Spectrum fans around the world.
ZX Spectrum Plus 3 was probably my most favorite machine. Absolutely love that thing. But I must admit, once I moved over to the Amiga 500, that kicked ass.
Thank you.
You are welcome. Thank you.
And Ken's going to give it a nice tour of Western Canada, and then, I think, send it off to Australia. Okay, so that's it for now. It's been fun getting to know this little computer. Make sure you follow its adventures on the playlist that's in the video description. Thanks to all past and future custodians of the Roaming Spectrum, and especially Matt for his work on this particular item. And thanks to the writer of this article way back when, Rod Hopkins of Leslie Fife. And this magazine is available on archive.org, and I highly recommend you check out the article. The whole program listing is there, along with an explanation of a lot of the parts, information on how to program the chip, and a lot more that I didn't get into today. Thanks to my patrons for their support, and thank you for watching. We'll talk to you next time.